This is part 4 of this series. This is about Pulsar SQL, or the data abstraction. Just a quick summarize. So we've been talking about how Apache Pulsar can really function as a data fabric for an enterprise in every capacity that a data fabric is sort of meant to be. And the abstraction layer of the data is really important. So a lot of people find it very valuable to be able to run SQL against a stream of data. Typically because most people, like data scientists, are trained in SQL, at least loosely. They understand that concept. Whereas dealing with data sort of partitioned by topics and things of that nature, I don't think it's a huge leap of a difference. But the fact of the matter is, like, today they're already familiar with SQL, so it's a little bit easier. Also, you really can just write less code at the end of the day to get the data out that you want, and that's always a good thing, because the more that the data scientist is focusing on machine learning and the math at the end of the day, that's just better for the company. But in general, the abstraction concept of Pulsar, so it is the idea of virtualizing the data. So it's sort of querying the data in place. Behind the scenes, Pulsar uses PrestoDB. So PrestoDB is a fantastic piece of software. It will take the data as it exists in Pulsar and make it queryable via SQL. That's really all it is at the end of the day. So you can sort of do select all or joins or anything of that nature to sort of bring back that data in any way you want. You can go back years worth of data. You could get data just from today. Really anything you could imagine with SQL, and it's a query in place, so it's not sort of moving it, which is very fascinating. So and because this is Presto behind the scenes, you can now treat it like a proper abstraction layer, not just of Pulsar but of anything. Because it is Presto, you can go add other databases to it. So then what you would have is you could then write an SQL query where you're selecting and joining from Pulsar with something like Redshift or Postgres or MySQL. So that is quite a fascinating concept. It's meant more as a sort of analytical nature to it. There's no caching layer to that. So you write these queries that normally, to do this sort of cobbled together yourself would take hours to days even potentially, with how much data you're querying. Presto sort of splits that and is incredibly efficient at it and pulls it back in seconds to minutes. So it's quite fascinating how it actually does that. And Presto itself is a phenomenal piece of software. There's a number of companies out there doing this. Denodo at the beginning, which I mentioned, who talks about a data fabric, they're very much in this space. They're all about data virtualization. And we know of a number of large companies who use them specifically, but also things like Apache Drill and PrestoDB, which we're talking about here right now. But the abstraction layer of data is super critical. It's baked into Pulsar, but it's a core component. If a company doesn't have that, I'll certainly invite them to do that. It allows you to sort of iterate quickly on the data from an analyst perspective, but you can turn it into a sort of functional component that could power dashboards. To do that, all you really need to do is add a cache layer, which is pretty straightforward, and there's out-of-the-box things that can sort of do that for you as well. It would be like a piece of software you install next to PrestoDB, and it ties into those queries, and it just allows you, from a client perspective, to cache them for a certain amount of time, or if you issue that command again, to sort of bypass the cache. It's really just a traditional cache layer, but there's a lot of intelligence to it. But that would allow you to sort of not have to go out to those data sources when you issue the query. So if you want to power a dashboard by it or something along that nature, it works very powerful for that. But the core concept of those abstraction layers are more from an analyst perspective. It's sort of exploratory and iterative. It's not meant to sort of be the backing to an API or a dashboard unless you add a bit more to it. But again, it's not super complicated, and it can do that incredibly well. because of how efficient it is at querying the data. Huge amounts of data, petabytes of data. If you have sort of minimal amount of data or only a couple sources, well, I would say if you have like one source and not much data, I don't see a lot of value there. If you've got a couple sources, there's really good value to the virtualization abstract layer, just because it sort of unifies the access to those multiple systems, and that can be incredibly valuable for tools like Tableau and Power BI and things of that nature. Even feeding data into Spark. That's why I think the abstraction concept or virtualization is very popular with data scientists, because otherwise they'd have to go to those sources themselves and join them themselves. That can be an arduous task. So having a single point of entry in there where they can sort of do that joining with, SQL, and then they can sort of feed it into their cleaning script or whatever they're trying to do. It's just easier for them at the end of the day. So Pulsar SQL is a fascinating component. It is just PrestoDB at the end of the day, but it's incredibly powerful to be able to run SQL against your topics. Specifically, PrestoDB requires a schema to be associated with the topic. So that means you have to sort of predefine the schema beforehand, and then you have to lock it to that in Pulsar, which Pulsar has a schema registry, so it's incredibly easy to do that. But some people have sort of semi-structured data in the form of JSON where the fields are ever changing. That can be a bit more complicated, although it can be done. It's more complicated if that schema is constantly changing. I mean, if you really just think about it from a programming perspective, it's incredibly hard to handle arbitrary JSON fields if you're imagining it could be any sort of data type, and you've got to massage that into other systems if you're doing like a join. It's just a hard thing to do at the end of the day. Apache Drill sort of out of the box does this where it doesn't need sort of schema ahead of time. But if you're ever curious, go look at the code and how they actually do that. It gets incredibly complex. So for me, I wouldn't attempt things like this without being like something that's strictly on a schema. But it's certainly possible at the end of the day. And right now, Apache Drill doesn't connect to Pulsar. But I know that the team behind that is currently working on that. But so that's data abstraction or virtualization in a nutshell. It's built into Pulsar, very powerful. It's an exciting sort of function. Allows it to tie into really anything that has the ability to connect and execute SQL, which is tons of clients out there these days.